a couple things. One is just kind of another unusual type of problem. The last video we saw what happens if you have a no b, where your no b term, so your y-intercept will be the vertex. Now we're going to look at one that has a double bounce, and this one has a double bounce, and I'll kind of talk you through that and what it means, and then we're going to work backwards. Again, I know we did that in a previous chapter, but now we have y-intercepts, so it'll be a little bit more complicated, but not too bad. I still think it's easier than what we've been doing. So long story short, initial factoring, there is no initial factoring here. So I will set up my diamond. A times C is 100. B is negative 20. I will put 4x on the side. I'll go through my number of combinations. 1 times 100, I'm not going to get a 20 out of that. 2 and 50, I'm not going to get 100 out of that. 20 out of that. 3 doesn't go in. Remember, 1 plus 0 is 1, and 3 doesn't go into 1, so it won't go into 20. 4 and 25, I'm not going to get a 20 out of that. A 5 and a 20, I'm not going to get a 20 out of that. 6 doesn't go in. 7 doesn't go in. 8 doesn't go in. 9 doesn't go in, but 10 and 10, that actually might work right there, especially if they are both negative. So negative 10 times negative 10 is 100. Negative 10 plus negative 10 is negative 20. Now I will simplify the side fractions. 2 goes into both of these. I get 2x over minus 5. And I get 2x over minus 5. So this is going to factor as 2x minus 5 times 2x minus 5. At this point, I will solve for the x-intercepts. So this is our step 4, our step 5. I will say 2x minus 5 equals 0. You'll notice I'm going to get the same thing twice. My kid screwed up my tablet. Hold on a second. I'm going to pause and make this thing work again. Child's been using my tablet for school, and he somehow managed to break it. Even though if you ask him, he says he didn't. Anyway, so I'm going to get the same thing twice here, right? So 2x equals 5 divided by 2, x equals 5 half. So I get 2.50 and 2.50. So these are going to be my x-intercepts. And I have the x-intercepts twice, which is kind of weird. Now we will go here and do step 6. So we'll plug in a 0 and figure out our y-intercept. Well, obviously I will get 0, 25, right? That's my y-intercept. And again, that nice shortcut of 0 squared is 0 times 4 is 0. So this is all 0. Negative 20 times 0 is 0. So I have 0 minus 0 plus 25. So really, you know that the C term is going to be your y-intercept. It's just a nice shortcut. If I go to 7, I need to get negative b over 2a for my axis of symmetry. So negative b, a negative 20, hopefully we're all okay with that, over 2 times a. So we're going to get a positive 20 over 8, which if you think about it is 2.5. Which, that's starting to look familiar because I already know what happens when I plug 2.5 into this equation. I get a 0. So this is my axis of symmetry. So let's go ahead and plug that into the equation. This would have been way easier to do as fractions, but I'm doing it as a decimal for some reason. So I will use a calculator. Maybe that's why everybody thinks they're easier. So I will say 4 parentheses. Remember, I just want to make sure my order of operations are okay. So I'm going to go ahead and type this whole thing in so that it looks exactly. So 4 parentheses 2.5 squared minus 20 parentheses 2.5. And again, the parentheses and stuff are a really big deal. That way the calculator gets my order of operation right. And that's not what I expected to see. Hold on a second. I screwed something up here. Give me... I'm sorry. Hopefully you did too. It would appear here that this is a 25 and I wrote a 20. So my mistake. This should be a plus 25. So when I go into the calculator, this should have been 4 parentheses 2.5 squared minus 20 times 2.5 plus 25, not plus 20, and we would get 0, which is definitely what I expected to see there. So that was a little bit frustrating, but at least we have it solved now. So we have a vertex of 2.50. So if we go ahead and look over here, we can see what's going to happen. I have this equation. If my x-intercepts are the same thing twice, we have what's known as a double bounce, and that becomes your vertex. So if I go back over here, you can see I had the same x-intercept twice. And if you have the same x-intercept twice, it's known as a double bounce, and that actually becomes your vertex. So again, you can see my x-intercepts happen twice, and they happen to be where my vertex is. So kind of interesting. All right, let me go ahead and set up the rest of the video. Okay, so we've already done this in chapter 4, where we started with the x-intercepts and we worked backwards to get the equation. Now what we're going to do is we're going to start with our x-intercept and our y-intercept, and we're going to work backwards to get the equation. So what if we were told that our y-intercept is 0, 21, and we were told that our x-intercepts were -3, 0, and -7, 0. So hopefully you guys remember this last time, that what we did was we said, all right, and by the way, we're just going to pick up right where we left off in chapter 4, which is we started right here. This is only going to help us, the y-intercept is only going to help us check our answer at the end, and hopefully you'll see what I mean in a minute, but we're just going to work backwards. So I have my solutions. I'm going to come up with the factors. Hopefully you guys all remember that's going to be x plus 3 and x plus 7, right? Those are the working backwards factors that I would get. Now, instead of using the diamond, we decided that we were going to use the area model. So I have x plus 3 and x plus 7. I'll get x squared, 3x, 7x, and 21. So I'm going to come up with the equation y equals x squared plus 10x plus 21. And now I'm just going to check, is my y-intercept correct, right? Because I might need to multiply the a, right? I might need to change the a and make this thing steeper or flatter or whatever. But if you look at it, in this case I don't. My y-intercept is 21, so I've sort of checked that, and I'm okay with that. And again, hopefully you guys remember doing this. I know we did this in chapter 4. So what do we get if we have something that we have a y-intercept that is 15? All right, this is our y-intercept, and we have x-intercepts that are 3 and -5. And again, I think you should pause the video. I know people probably rarely do, but you should pause the video and try and figure this out for yourself. So the first thing I'm going to do is figure out what factors go in here, and I'm going to get these factors, right? If I plug a 3 in here, it turns into 0. If I plug a -5 in here, it turns into 0. It's all about that zero product property. Now, on the sides, I have x -3. I have x +5. I will get x squared minus 3x, positive 5x, minus 15. So when I write this equation, I'm going to get x squared plus 2x minus 15. But we have a problem, right? My intercept should be 15, but it's -15. So if you think about it, what I really have here is I have this a out front that I don't know what this a is, but I know that if I multiply a by -15, it should equal positive 15. Now, hopefully you guys already know what a needs to be, but I do want to show you algebraically. This number, -15, right, times this number a. When you multiply a and -15, it needs to equal 15. So just doing a little bit of algebra is going to show us that our a needs to equal -1. So what that means is this is going to be my equation. And so I will get -x squared minus 2x plus 15 as my equation. So I didn't throw the first one in Desmos, and I didn't. Let me go ahead and pause right now and just put both of these in Desmos so we can see that in fact they have the correct y and x intercepts. You can see we had x squared plus 10x plus 21, and the x-intercepts are supposed to be -3, -7, and the y-intercepts are supposed to be positive 21. So there we go. You can see -7, -3, positive 21, and you can see we have that equation, y equals x squared plus 10x plus 21. For the next one, the one that was a little bit more complicated, where we had to introduce that a as a -1, and hopefully you caught that. Again, y-intercept of 15, x-intercepts of 3, and -5. So there we go. -5. Geez. Positive 3, 15. So we have those x-intercepts and the y-intercept we want, and you can see the a needed to be negative. It's opening downhill. Let's do one more of these things. Again, I would love it if you'd pause it and try it as we go, and sort of see what you come up with. So the last one that we will do, we will get a y-intercept. Actually, I guess I gave you a few more of these. So, all right, I guess there's going to be 3 more. I don't know if I'll do all 3. Maybe I'll do 2 more. So I have a y-intercept of 0.48, and I have an x-intercept of -4.0 and -6.0. First of all, I apologize if I got your hopes up. I'm probably going to do all 3. All right, so first of all, I'm going to do the factors. So x plus 4 and x plus 6 are going to be my factors. Hopefully we're okay there. Over here, I'm going to have x plus 4, x plus 6, x squared, 4x, 6x, 24. So x squared plus 10x plus 24, and it's supposed to equal 48, right? So again, I have this sort of a. So I'm just going to say 24 times a equals 48 divided by 24. My a looks like it needs to equal 2. So 2 is going to be my a. You can see I just swapped that out right there. So a little bit more problematic, but nothing too difficult, right? And now we'll check this answer and sort of see what comes up. So let me go to Desmos and set this up. By the way, before I do that, we have this equation. Y-intercepts 48 and x-intercepts are -4, -6. That equation did in fact work. We have our y-intercept of 48 with our x-intercepts at -6 and -4. So checking that a and the manner that we did it in the last 2 problems is really important. So let's do a couple more of these and then wrap it up. Alrighty, so here we have x-intercepts of 20 and -2 and y-intercepts of 0, -40. So we'll go ahead and make our factors. Again, I know I'm going through this, I don't know, maybe quickly, maybe slowly, depending on who you are, but you really should be trying these videos, trying these problems on your own to see kind of what you come up with here. So it looks like here, I might be done already, right? If you check your a, you can see that the a works. My y-intercept is fine here, so let's go ahead and throw this in Desmos and see what it looks like. So you can see we didn't even need to change the a on this one. Leaving it as 1 was fine. We have -2, positive 20 for x-intercepts, and 0, -40 for our y-intercept. Let's do the last one. Okay, I definitely think this one might be the trickiest one, but if we go through the steps the same, everything should be fine. So our factors are x minus 2 and x plus 4. We go to our area model. We have x minus 2 on the side and x plus 4 on top. So I'm going to get x squared plus 2x minus 8. Now think about this. My y-intercept needs to be -4, but it's actually -8. So again, I'm going to go ahead and multiply. This a times -8 should equal -4, but it doesn't. So I'll divide by -8. And my a will equal -4 over -8, which a negative divided by a negative is positive. So I'll get 4/8, which is obviously 1/2. So my a is 1/2. Now it's kind of up to you what you want to do here. I'll distribute, so I'll have 1/2 x squared. Half of 2 is 1, and half of -8 is -4. So this will be my equation. And again, my equation needs to have x-intercepts of 2 and -4 and a y-intercept of -4. So if we go over here and see, you can see I already have that. So 1/2 x squared plus x minus 4. I have -4 and +2 for my x-intercepts and -4. So sometimes our a might even be divided. And again, that's why I think it's such a good idea to just write a simple algebraic equation. This times this needs to equal this. And that's just the last check we do. That's the only part that we're adding, right? All this other stuff we'd already done before. But the last thing we're doing is something times our y-intercepts needs to equal our y. Something times our c needs to equal our y-intercept. And then we multiply that and then see if we need to manipulate that with an a. So hopefully that made sense.